Okay, in this video, we're going through example number 6, which is reviewing how to go through a grams to grams conversion for it. So we are using this combustion reaction on top. C4H12 plus 7O2 yields 4 CO2 and 6 waters. So if you begin with 2 grams of C4H12, how many grams of water will be formed? Now notice that I already color coded my stoichiometry, letting us know that our blues were my A's and my yellows were my B's. So now let's go back to the problem and find the number that's given. And we see that the number given is our 2 grams of C4H12. So that's going to let me know that this is my A. So now let's find our B. We're looking for how many grams of water. So I find water on my product side as my B. Now we don't care that there are 4 CO2s or 7 O2s for this problem because we're only focusing on how much does our hydrocarbon produce in our water for it. So remember, our given's going to go first. And we see that our given is 2.0 G of C4H12. So then we need to follow the units, and we'll see that grams goes on the bottom, and grams is always per 1 mole of it. Then our next step is going to be our mole ratio. And before we get to that, you'll notice that I'm missing the number with my grams, and that's what I need to get from my periodic table. So if we look on the periodic table, we see that carbon is going to be 12.01. So we're going to do 4 times 12.01, and that's going to give us 48.04 for it. And then we have H, which is 12 times 1.01, and we're going to get 12.12 for it. So we just need to add up these two to find our answer. So hopefully you have your calculator out and ready to go for it. So if we do 48.04 plus 12.12, we're going to see we get 60.16 as our bottom part. So now, if there's no number in front of our chemical formula in our balanced chemical equation, we assume it's a 1. So we're going to have 1 mole of C4H12 on the bottom. Then we look at our B, and we're going to have 6 moles of H2O. So we keep following down our mole of H2O. Unless it's in this mole ratio, it will be 1 mole. And then we have to find grams of water here. So we'll see H is equal to 2, which is 1.01 on the periodic table. That's 2.02. And then O is equal to 1 times 16, which gives us 16, 18.02. Now remember, whenever we're doing molar mass, we're only looking at the formula, not the coefficient for calculating it. So double check that your units cancel out. So grams to grams, moles to moles, moles to mole. And we're now in the unit that we want for it. I'm just going to get rid of that red line because it kind of looked confusing for it. So now we're at the end. We have to multiply the top, multiply the bottom, and then divide top by bottom. So let's do the top first. We have our 2 times 6 times 18.02. So 2.0 times 6 times 18.02, and we get 216.24 as our top. Then we multiply the bottom. We have 60.16 times 1 times 1, so we're going to have 60.16. And put it in our calculator, and we see we get a very long decimal. So 3.594414894. Go back to your problem. We have 2.0 grams as our given. So if we have a 0 to the right with a decimal, that would mean that we have 2 sig for it. So 1, 2, will 9 round 5 up? Perfect. It does. We'll have 3.6 grams of water. And so what that means is that if we started with 2 grams of my hydrocarbon, we would produce 3.6 grams of my water. So thanks for watching as we work through example number 6.